we can code now 10 times to 100 times faster leveraging this technology. So if I'm a betting person, no, I think all of these problems will be solved by the end of next year.
Good morning, good afternoon, or good evening, depending on where you're listening. Welcome back to AI and the Future of Work. Thanks again for making this one of the most downloaded podcasts about the future of work. If you enjoy what we do, please tell a friend, and we'll keep sharing great conversations like the one we have for today. I'm your host, Dan Turchin, CEO of PeopleRain, the AI platform for IT and HR employee service. We learn from AI thought leaders weekly on this show, and the added bonus is you get one AI fun fact each week. Today's fun fact comes from Richard Van Norden, who writes in Nature Online. ChatGPT-like AIs are coming to major science search engines. Now, we've talked about this on previous episodes. LLMs dedicated to science search are proliferating. Richard summarizes a lot of the current state of options and activity in this space by saying AI-powered chatbots are increasingly being used in scientific research, with just in the past couple of weeks, Elsevier, Digital Science, and Clarivate all announcing plans to launch chatbots just for their own content. In 2023, these chatbots use LLMs to answer natural language questions about research topics, providing summaries of research findings, relevant references, and further questions to explore more. LLMs can be used to identify and correct errors in the literature. They can also be used to identify emerging research trends and to generate even new hypotheses. As always, we will link to the full article in today's show notes. And that one's actually somewhat relevant to the great conversation we have scheduled for today. Shifting to this week's conversation, semantic search using natural language where results are returned using conversational replies versus links is quickly replacing the search paradigm that has been the predominant mode of search since the earliest days of, let's say, Lycos and Excite, even before we had Yahoo and Google. We've discussed the future of knowledge retrieval with great recent guests like Dee Das, CEO of Sorcero, and Eric Olson, CEO of Consensus. Today, we get a real treat. Amr and I met on a genAI panel, and everything he said was both insightful and contrarian. Immediately, I knew I wanted to introduce him to you, our audience. Amr's a legend in the search space who, by the way, also founded Cloudera, which went public in 2017 at a valuation of over $5 billion. Dr. Awadallah is a luminary in the world of information retrieval. He's not only the CEO and co-founder now of Vectara, a company that's revolutionizing how we find meaning across all languages of the world using the latest advances in deep neural nets, large language models, and natural language processing. Amr previously served as VP of Developer Relations for Google Cloud. Prior to joining Google in 2019, he, as I mentioned, co-founded Cloudera. In 2008, and served as its global CTO. He also served as Vice President of Intelligence Engineering at Yahoo from amazing years, 2000 to 2008. Amr received his PhD in EE from Stanford and his bachelor and master's degrees from Cairo University. And gosh, without further ado, Amr, it's my pleasure to welcome you to the podcast. Let's get started by having you share a bit more about your background and how you got into this space.
No, it's my pleasure to be here. I'm not going to share more about my background. You already did an excellent job there reciting my background. But in terms of how I bumped into the space, like the generative AI / large language model space, I was at Google Cloud, head of developer relations, vice president of developer relations over there. And Google Cloud has many, many products. And it's not just AI. There's many, many aspects of the Google Cloud platform. But while there, I got to see the power of large language models a couple of years, I would say, before other people would see it. And it was truly just like the reaction everybody else had when they started interacting with ChatGPT for the first time. It was truly inspirational for me to finally be at this point in our time as a human civilization where we are able to talk to our software and tell our software what we want, and it understands us in the same way that we talk to each other. So it was clearly an inflection point that for me was very similar to Windows 95, if we go back to 1995, or the iPhone in 2007, which by that I mean a significant elevation in the way that humans are able to interact with software. So before Windows 95, the only way we could interact was via the command line, and we had to remember these commands. There's a bunch of a preset defined list of commands that we had to remember and all the options they can take. So very few of us could use that, right? And then Windows introduced the notion of a menu and a mouse, and now you don't have to remember the commands, you can navigate the menus, and that opened up consumption to a large group of people. But we had to rewrite all of our apps to take care of that new modality. And then the same thing happened again with the iPhone and the touch screens around the mid 2000s. We could now use our fingers to swipe right, swipe left, pinch in, pinch out. Again, that was a lot more natural. We all have fingers, we all know how to use them. And that opened up consumption to a way bigger population of people. But again, we had to go and rewrite all of our software and apps to take care of that new modality of interaction. And now we are finally at the stage where we can just talk to our software like talk to each other, whether that be verbally spoken or written. And we're very close to getting to the point where we can get the software to do what we want based on what we're saying. So that's that kind of realization that I came across while at Google, coupled with the fact I met a couple of very, very smart engineers that were working on this technology, were the genesis for Vectara. And that's why Vectara came to be.
There's a very small community today of people who are on the bleeding edge of generative AI, and I'd count you in that inner circle. I feel like the closer you are to the technology, the more that you realize that it's pathetically immature in its current state. Without overly editorializing, I'd love to get your perspective as a technologist who works with this stuff every day. What is the current state of generative AI?
Yes. First, we have to put things in perspective. I mean, it is definitely a very impressive state compared to 10 years ago. If you compare it to 10 years ago, it's absolutely mind-boggling what we have been able to accomplish as all of us collectively working on this stuff. But yes, there is lots of building blocks that we need to fall in place and we need to gain confidence around before we can truly start putting this technology between us and between our applications. First and foremost, it's something we're all very familiar with and we experienced if we use ChatGPT, is the hallucination issue, right? And that's where the large language model can err on the side of making up, or sorry for the lack of a better word, bullshitting you in terms of a response based on the models and what it have learned. And that's a very intrinsic problem actually to large language models. So the way that large language models are created, you can think of it as it's compressing down information. We're taking petabytes and petabytes and petabytes of information and compressing it down to a few hundred gigabytes. So you can imagine that as a byproduct of that, it's gonna be lossy compression. You're not gonna have all of the original data stored in the model, right? So the model tries its best to come up with its recollection of what it learned, but by definition, it will patch in things every now and then. And that's where this issue of hallucination creeps up. Because it does not have a photographic memory of everything it has seen. It has a compressed version of everything it has seen. And by the way, that's very similar to how our brains work too. When we go to school and we spend 5 years working on our bachelor's degree or PhD degree, we're not going to remember everything from it, right? We're going to remember the essence of it. And so by definition, when you only remember the essence, you will tend to patch in the blanks. And patching in the blanks, that's where you can become too creative sometimes. So that problem is very fundamental to large language models. It's a very hard problem. Many of us are working in earnest to solve it because we know that before we can deploy large language models in critical business applications like finance or health or manufacturing, we have to resolve these issues. We cannot have the large language model going in and every now and then, even if there's a 1% chance it will make that mistake, we can't afford that. So that's one of the very fundamental problems that we're all working on. We believe at Vectara we have a good initial solution for it. There are some other secondary problems which are also concerning. One of them is the issue of bias, and that the large language model, they learn from us. So by definition, if you're not careful with what you're feeding it, you can end up with a model that's very biased in some way or another, along many, many dimensions. Very hard problem to track down and solve. And then last but not least, the issue of copyright infringement. And we're seeing a lot of book publishers now going after OpenAI and suing OpenAI. Oh, your neural network learned from our chemistry book. Your neural network learned from our biology book. We know we need to resolve these issues as well, and the resolutions for them are not just technology resolutions. I think we need some legislation and some governance around how that is done. And it's, by the way, a topic of debate. Like you, Dan, you're allowed to read any chemistry book you would like and learn from it anything you would like, and that's why the book is there, is for you to learn. So why can't the large language model learn from a book? As you know, it's a very contentious topic. The US doesn't have a clear, firm rule yet, but some country like Japan, for example, now just said, yes, if you're learning from it and you're just learning, you're not copying it verbatim, you can go ahead and do that with a large language model. We don't have a clear-cut rule yet in the US, and we'll see how these things materialize in the courts, as we have all of these lawsuits going on right now against OpenAI and against Stability AI, the founders of Stable Diffusion. So we'll see how these things will materialize themselves.
You mentioned how much progress we've made in, let's say, the last 9 months versus, let's say, the previous 10 years. And one of the things I wonder is, given that rapid pace of innovation, when we're back here in, let's say, 2028, in 5 years, which of those fundamental issues that you just described do you think we will have resolved by then?
Oh, that's an excellent question. 2028 is a very long time. That's 5 years, which, given the rate with which this technology has been advancing, and by the way, has been helping us advance. Like we can code now 10 times to 100 times faster leveraging this technology. So if I'm a betting person, no, I think all of these problems will be solved by the end of next year at the high end. So we're talking about a year and a half before we find very, very good solutions for the hallucination problem, for the copyright problem. Maybe the copyright problem will take a bit longer because that involves people making decisions. So that one, maybe I'll give it a couple of more years on top. But for hallucination, for bias, I think we'll have very, very good solutions by the end of next year.
I've asked that question many times, and I've never heard anyone with such confidence state that within 5 years, all of those problems might be resolved. So look, or sorry, you said within 1 year. You're on the record now, so yes. We're gonna book you for a year from now. We're gonna come and have yes. another version of this discussion. All right?
Yes, please do. Please do.
Now, like you, I grew up in the search space a long time ago, in the internet search space, and looking at some of the amazing developments in search technology since the 90s. Like you, I mean, it boggles the mind. Analogous to the advances we've seen with generative AI through the transformer architecture. My question for you is, given that you continue to reinvent search, is it the business model of search that's the problem? Is it the underlying retrieval mechanisms? What fuels your passion to believe that there's always something that can be improved upon in the realm of information retrieval?
I think it's the underlying product itself. So the product is changing now. In a significant way. So again, over the last 10 years, definitely large language models was a major innovation, but also information retrieval and how we can find information based on its meaning and based on comprehending and understanding it versus simply matching patterns, meaning the keyword Dan appeared over here and the keyword Dan appeared over there, then this is a good result. No, now we know who Dan is, what they're doing, what the context is, and these models are able to properly classify, categorize, and find based on that. And that's what we call the embedding space or the vector space, which is another reason why our name is actually Vectara as a company. It's going after that notion of a vector. And the vectors, they are the meanings, right? So these neural networks learned how to go from our language space, meaning English, Japanese, Chinese, German, French, into a universal embedding space or a universal meaning space. It's almost like they came up with their lingua franca that can encode all of our meanings and understand them at depth. And that's significant innovation. It's just as fundamental, if not more fundamental, in my opinion, than the large language models themselves. In fact, they underlie how the large language models work. If we have not figured that out, we wouldn't have figured out large language models. So now, for the first time in history, we are able to go after the meaning and get you an answer for your question, right? So we're moving away from the old way of doing things, which was search engines, and then the search engine gives you back a list of results that you have to read to verify whether one of these results has the answer that you're after, to now you can not search, you can ask. So I like to say we are in the era of the answer engine. And the answer engine, you ask the question, and instead of a list of results, you get back the answer. It reads all of the results for you. It sees all the different points of view that might agree with with the result or disagree with it, and present all of that for you in a very unbiased, concrete answer to the question and the idea and the thought you're after. And I believe that was the underlying thing that made ChatGPT, for example, with consumers just explode. ChatGPT, as many of us know, it's the only organic growth service that was able to grow from 0 to 100 million users in a few weeks. That has never happened in history before. And I think it's the first impression that most people, when you ask them, was what made you excited about it? And it's like, because I could just ask my question and I get back a cohesive answer that truly is answering this question. That was number one. Number two was, of course, how good it was at manipulating language. Like, please give me that answer now as a poem, or please give me that answer now in the style of Feynman, and how Feynman explains concepts. That was also impressive. But the first thing that really got people was, wow, I can now get answers. So I think that's the fundamental shift. Now, business model, you touched on, that applies more to consumer search engines like Google and others. And yes, there is a business model tension there, where we do have these ads that show up on top of our answers. And these ads are how Google and others make money. And you can see how the ads can get in the way now. If you're getting an answer to your question, where are you going to put the ad? So that's a very big topic of debate, and we'll see how that evolves over the next few years.
As a consumer, prior to the GPT family of models, I thought that Google owned semantic search. I mean, when I ask about the Warriors being in the Bay Area, it's reliably going to tell me about the Golden State Warriors and not about the Terracotta Warriors in China. So to me, it seems like a business model impediment that has stood in the way of this innovation coming out of Google. So as your former employer, do you feel like it poses an existential threat because search as a function is being reinvented?
Yes, it does. But I mean, first, I will note that they absolutely have the technology internally to do this well. Like, so in terms of can they do it? Absolutely, they can do it. And in fact, right now, I already opted in to the feature in Google search where they will give you the generative response, right, by default. So you can opt into that right now, and it gives you the answer. It gives you a generated answer to your question right away. Now, as more people adopt that, will that now start to detract from the revenue that they make from advertising? I think the answer is yes, because if you have the answer right there, why would you look at the ad? But then, can they embed the ad in a very natural, homogeneous way and constructive way where there's value back to me? Because for some questions, actually, the ads are the right answer. Like if you're looking for a solution, for the service, for something to buy, the ad might be the answer you're looking for. So will they figure that out, how to weave that in organically within that experience without destroying the experience? Then that would be their salvation. And I think they're working on that. But if they can't figure that out, yes, that will be an existential threat, because now the answer is what the people want, and they will start ignoring the ads completely.
You talked a little bit about the problem of hallucination and what could be up ahead. I know a big concept at Vectara is grounded generation.
Yes.
And I would love for you to introduce us to the concept and why it might solve the problems that are really constraining adoption of LLMs today.
Yes. So as we highlighted at the beginning of conversation, the reason, one of the key reasons, it's not the only reason, but one of the key reasons that the large language models can make up stuff or do make up stuff or need to make up stuff is because they are a compressed down representation of knowledge, right? So they're taking all of it, and truly it's mind-boggling to see how much we're able to compress the entire knowledge of the world in a few hundreds of gigabytes of weights in a neural network. It's truly impressive. And it's one of the things that's mind-boggling for all of us researchers and everybody being exposed to this, is how effective that method is at compressing down information. So how do you solve the hallucination issue? It's very simple. How would you solve it if you were a human? You would solve it by having photographic memory. If you have a photographic memory around the concepts that you are providing opinions about or providing answers around, then the probability of you making a mistake will be much lower, because now you're grounding your conclusions, you're grounding your summaries, you're grounding your answers in these underlying facts that are coming from that photographic memory. So that's what grounded generation is about. So grounded generation is, we're going to have 3 neural networks working hand in hand. Actually, it's not one neural network. There is one neural network that is focused on providing the summary, the generative output, the response. But there is also a neural network that runs at the beginning that is focusing on, given all the documents that you have as a company, giving all the documents that you have as an organization, what are the most relevant facts in these documents that have to do with the question you're asking right now, or with the prompt that you're issuing right now? And that requires very deep semantic understanding. So I need to semantically understand your prompt or question. And then based on my semantic understanding of your prompt of question, I now need to match that to my semantic understanding of all of the underlying documents to find the 10 key facts or maybe 20 key facts that are most relevant to that question and present the different viewpoints around that question, right? So that's number one step. We find these facts. And then there's another neural network that comes in now and says, okay, now I'm going to apply even deeper understanding, which takes more computational power. So you don't want to do it on the full data set. You want to do it only on a subset of the data set. Of these 100 facts I just found, I want to reorder them so that the number one fact is the most relevant fact, the second fact is the second most relevant fact, etc., right? And introduce this variety in viewpoints in that sorting order. So how can I sort the facts as a function of the question you asked so that the facts are maximizing the information content relevant to what you're after, okay? And then once I have that sorted list of facts, that's it. Your job now is done. You give these facts to the large language model at the end, and you explicitly tell the large language model you are sandboxed into only providing an answer to this question or this prompt, and the only knowledge, you can use your understanding of English language, you can use your understanding of the domain, meaning law versus manufacturing versus engineering versus medical, but don't introduce knowledge outside of these facts we're giving to you, right? So read these facts and then answer that question, leveraging your knowledge, but stay within these facts. So by constraining the model this way, we now significantly reduce the probability that it will hallucinate. And by the way, it does still hallucinate every now and then, but it's a much more lower probability. And we are publishing soon an open source framework that people can use to measure the hallucination probability in cases like this. Second, by constraining it also to these facts, you're significantly reducing the probability of copyright infringement or intellectual property infringement, because now it's not going to, the large language model is not going to be relying on what it learned about the world, which might include some of that. It's only responding back based on what you have in your data. Of course, if your data and facts have copyright issues, then we're still going to have the copyright issues. But that's your mistake now that you fed that in. And then last but not least, it significantly reduces the bias as well. The large language model might have learned bias, but it's interpreting these existing facts as that's the truth right now. So again, the bias will be a function of the input facts, not what the model was trained on. So we end up solving 3 problems right away by doing grounded generation. Less hallucinations, less bias, and less probability of intellectual property or copyright infringement.
So that's an excellent answer, and it's mostly satisfying, but a little bit of it is dissatisfying, or yes, leaves me to ask more questions. So, as you said, if it's fed misinformation, then even the best GAN or generative adversarial network approach is still going to yield, maybe it'll filter out some of the most egregious misinformation, but it's still vulnerable to the integrity of what it was fed. Which leads me to another question that I know you're a bit of a philosopher at heart. So I got to ask, I mean, in this new world of generative AI, what is a fact? And what is truth anymore? If machines are generating all of this new content, whether or not we believe what the machine generates, at what point does what comes out of genAI introduce a new reality? And might our definition of a fact change as more of this infiltrates our daily lives?
As you correctly highlighted, that's a very hard question to answer, even without genAI. Even without genAI, like what's a fact? Like, as we say, history is written by the victor, right? So in many times, the facts we are seeing are not the true facts. It's the facts that the victor decided will be the facts we all need to align on. And there's few exceptions to that. I mean, science obviously can be a lot more rooted in proofs, and these proofs can help us establish that 1 + 1 = 2. But even that, like some new learnings you might have around the quantum mechanics will make us question that 1 + 1 = 2 in this condition, but under that condition, it actually might not, right? So in other words, establishing what is a fact and what is not, even before GenAI, was a very, very hard problem that we all are worried about. We also, what can happen with propaganda? We all know what can happen with propaganda when it's used in the right way or used in the wrong way. Propaganda does not come from GenAI. Propaganda comes from humans. We make up these things. Now, the unfortunate reality is GenAI will help us make it much quicker, will help us make it in a lot more personalized way. I can now create propaganda for Dan specifically that will trick Dan. So imagine now Cambridge Analytica, which was definitely a propaganda machine that was used in the Trump elections. Imagine that now with the ability to customize that message for every single person to lean into what they believe is facts, which might not be true facts, but that lean into what they are afraid of and their fears, and get them to say yes to a certain resolution or vote that you want to pass. I'm actually very worried about that problem. I don't have an answer for what the proper way for handling would be. One idea I have, which can be true, but might not, it requires research to prove out that it can work out, is we are going to need the antivirus of facts. Like, we have viruses for software. Viruses for software happens all the time, even though it's illegal, by the way. If you create a virus for software and the federal government catches you, you are going to prison, but we still have viruses happening left and right because we live in a global world, and we live in a world where not everybody is a nice person. But the solution was we're going to have regulations that prevent these things. That's step number one, which is great. But two, we're going to have technology that catches these things, right? So I think we need the technology that is an anti-propaganda technology, where if I'm hearing a message, Amr is talking to me right now, trying to convince me with something, a number will show up in the upper right corner. These statements coming out of his mouth right now, with a 70% probability, they're being said to manipulate you. They're not being said to truly educate you, right? Can we have something like that? I think we need that. Like, the future will need that, will require that. So maybe that's a startup idea for somebody to go work on.
I've often talked about the need for a hygiene score for models, kind of like a restaurant gets graded on its hygiene. So should an AI model. And I like that idea of some kind of an integer that assigns the likelihood that this is manipulative.
Yeah, like a bullshit meter.
Absolutely, and that's a good word.
You're being bullshitted right now. Like, no, yes. You are being bullshitted right now.
and as soon as we finish recording, please copyright that. All right. I love it. I love it.
Yeah, the bullshit meter. Yes,
absolutely. It'll go viral. So along those lines, another tough question for you. As a vendor who's disseminating these technologies, what is your responsibility? And whether it's the federal government, the EU, you mentioned regulation in Japan, who should be regulating this? And how, as a vendor, do you think the output of your models should be regulated?
That's an excellent question. So our model is being used for Vectara specifically first. We are being used internally within organizations. So we are not being built for the public population at large. We're being built for companies to leverage this within their companies. And we expect that with collaborating with their board of directors, with their chief information office, with their chief security office, that we can properly reach these balances for balancing truthfulness, meaning hallucination, for balancing bias, for balancing copyright infringement and such. That said, I wish and I hope our government moves faster. It's slow right now. Japan has moved really fast, which I was impressed by. Europe is about to issue a very, very comprehensive, I don't agree with everything in it, but a very comprehensive framework around generative AI technologies. We need to do that as well. And it's a qualm I have a little bit, where our government seems to be listening more to the top tier, top brass companies in the space. And frankly, they have their own selfish needs that they're going after. And I think they're influencing our government in probably not the best ways. When you listen to, I don't want to pick a certain company, but one of the big companies speaking to the government, they try to scare them and tell them, oh, the regulation should be only a few companies should do this, and we only trust them to do it, and we only monitor them. It's like, no, obviously that will lead down the wrong rabbit hole. Like anybody with half a brain would see that. That will give that a company too much control. Roll that forward 10 years from now, we are going to have Skynet. Right? You need to have multiple peoples working on these antiviruses, working on these techniques to make the models better. That's the only way we're going to keep this democratic, true, honest, and a reflection of all of us. So that's kind of my feedback to the government, is you need to include more of us in the decision-making process.
Yeah, this is not a 2-minute conversation. I agree with your perspective. I feel like we are inviting big tech to grade its own homework. And
yes.
Yes.
Like if you look at the drug industry, you don't ask the head of a drug company, please come and run the FDA. Like that's gonna be a big
There's
mistake.
a reason there's an independent FDA.
Yeah, exactly.
But to my opening comments, I mean, I constantly marvel at the comical immaturity of not just the technology, but all the infrastructure and the regulation and just how we introduce a disruptive technology like this into society. I'm not sure we're ready for it. And that's okay, but we're definitely not ready for it.
Yeah. No, I agree with you. I'm not ready for it, but we need to be. It's moving very fast. And if we don't get ahead of it, it can be dangerous. It can backfire. So I agree with you. I agree with you.
Yeah. And it's how innovation happens. And it's okay. Mm-hmm. It's a little messy. I got to get you off the hot seat. I feel like we're just getting started, but but not before answering one last question for me. Speaking of kind of the messiness of innovation, you're an amazing serial entrepreneur. And I would love to get your perspective. What's the hardest thing about high-tech entrepreneurship that nobody talks about?
Oh, wow. That's a very tough question. I wouldn't say high-tech only, but I would say entrepreneurship in general. The two hardest things I always encounter over and over again, at the beginning of your journey, it's product market fit, right? It's like making sure, wow, this technology is great. It's awesome. Large language models can do these amazing things. Embedding and information retrieval models can do these amazing things. Excellent. How can that solve a real problem in the real world that truly helps people? So finding product market fit, a lot of times us coming from engineering-centric companies, we lose that importance of tying it back to the customer and to the problem they're trying to solve. And that's the number one advice I always give, is like, always remind yourself of that. Get your first product out, even if it's not 100%, get the 80% out, because you want to get that feedback from your customer. Like, this is meeting me where I need to be, versus no, what the heck are you talking about? This is a useless product, right? So that's the number one challenge, bar none, at the beginning years, right? And then later on, at the later years, which you're in the middle of that tornado right now yourself, is execution. Like building a team that is executing like a symphony. Like everybody just singing the same tone, moving in the same direction, helping each other. Oh my God, that's such a hard problem to get done as a company is growing fast at the same time. It's stressful. It's nerve-wracking. It's an essential component of success. And if you don't get good at doing it, you will not succeed. So that would be the two key problems I will highlight.
As you've pushed yourself to the limits over the years, building teams, building companies, building technology, what have you learned about yourself?
That's also an excellent question. I love that question. I think during my, not just building companies, like just maturing from, I'm 52 years old right now. So during these decades, I would say one of the key lessons I've been learning over and over again is be authentic to yourself. Be authentic to yourself. Like, listen to other people, listen to their propaganda, like we said earlier, but leverage your authenticity and your understanding. Don't let that propaganda override your views. Come up with your own views. So that's my key message that I would like to give to anybody listening to me right now. Like, don't fall into the dogma of other people. You need to establish your own dogma.
Brilliant. Hey, we're out of time, but gosh, we're all rooting for you and for the team to succeed. If the audience wants to learn about your work and the work of Vectara, where should they go?
They should go to Vectara.com. That's the best place to learn more about Vectara. And I will highlight a very key benefit of our platform that I want to conclude with. Is one, there is so many people doing GenAI platforms, this or that, and one of the key areas that we're choosing to differentiate on is ease of use. Ease of use. We have a very simple platform. You upload your data with one API call, and you get amazing responses to questions with another API call. You don't have to worry which large language model I'm going to use, how I'm going to fine tune it to minimize hallucination, how I'm going to configure it to make it scalable, to make it secure. We take care of all of that for you so you can get your job done. So I just want to conclude by highlighting that.
We'll link to all that in the show notes as well.
Thank
well,
you.
Amr, this has been a lot of fun. I look forward to our follow-up a year from now. When we're going to unpack those prognostications.
Where all these problems have been solved. Yes.
You bet. All right. Well, that's all the time we have for this week on AI and the future of work. As always, I'm your host, Dan Turchin from PeopleRain. And of course, we're back next week with another fascinating guest.